It's no comet, and it didn't originate here. Only a few months back, 3I/Atlas appeared as a faint greenish smudge at the solar system's fringe. Today, it's hurtling sunward at close to 70 kilometers per second, enveloped in an enormous coma that eclipses entire planets and shifting to a foreboding crimson hue. Yet the real surprise lies in its erratic hues, which defy chemical logic. The radiance flickers unpredictably between red and green, while the nucleus stays utterly concealed, spanning perhaps the length of an urban district up to a full mountain. With 3I/Atlas adopting this ruddy tint, what secrets does it unveil about its origins? And what precisely are we observing as this extraterrestrial wanderer surges toward Mars and the Sun right now? 3I/Atlas traverses the inner solar system at roughly 68 kilometers per second, equivalent to over 240,000 kilometers per hour. That's swift enough to span the Earth-Moon gap in under 90 minutes. By contrast, it outpaces Mercury's orbital velocity by double and exceeds the inbound rush of typical long-period comets by more than tenfold. This isn't a leisurely glide across the void, it's a dynamic surge, an intruder from beyond solar influence, diving in with vigor that overshadows local planetary motions. The path of 3I/Atlas follows a hyperbolic arc, unbound to the Sun, merely a singular transit. Its approach velocity, exceeding 60 kilometers per second pre-perihelion, eliminates any chance of birth in the Kuiper Belt or Oort cloud. Such relentless pace signals an authentic interstellar voyager, free from the gradual, curved paths of homegrown comets. Speeds of this magnitude unleash colossal forces. As Atlas charges ahead, solar rays and winds batter the coma, eroding substances and energizing particles at an unprecedented clip. The immense kinetic power from that 68 kilometers per second velocity suffices to sublimate icy coatings and eject debris in a burst of frenzy. Each instant, it spans a span akin to a modest nation. These metrics stray far from standard comet studies. This represents an anomaly, an entity advancing with excessive velocity, linearity, and force to conform to solar system natives. Encasing 3I/Atlas lies a powdery sheath of staggering proportions, challenging comprehension. Even elite observatories like Hubble, Gemini, and the Nordic Optical Telescope capture merely a dim luminous veil, its boundary blending into cosmic obscurity. Composed of dust and vapor propelled by sunlight, the coma stretches for thousands of kilometers, obscuring any hint of the solid center. At most, detailed scans limit the nucleus to under 5.6 kilometers in diameter, though reflections of solar light suggest extremes from mere hundreds of meters to as much as 50 kilometers, a variance spanning 2 magnitudes. The sole assurance. The core is overshadowed by its emissions, buried within a fog potentially several times Mars' breadth. Such dimensions pose more than visual awe. They create analytical hurdles. Efforts to gauge the nucleus consistently falter against the same barrier. The coma vastly outlumens and outmasses the core, diffusing illumination and concealing its actual form. Despite superior observations, experts grapple with approximations, not precision. A diminutive core would mark it among the smallest interstellar finds. A grander one might match the largest comet cores known. Absent a probe rendezvous or ideal stellar eclipse exposing the depths, 3I/Atlas's essence persists as an enigma, sparking arguments on its nature and nomenclature. Within the International Astronomical Union's halls, designating 3I/Atlas stirs contention. Echoing Pluto's reclassification saga, which echoed for years, this interstellar rarity elevates the controversy. Online platforms echo every conjecture, while outreach specialists handle inquiries from schools and broadcasts. Is it best termed a comet, a shattered worldlet, or an unprecedented entity? Lacking solid proof, hasty labeling risks eroding credibility, blurring conjecture and reality. Currently, the Council holds firm. Bide time for evidence, sustain narrative coherence, and brace for revelations that might rewrite the tale. The inaugural polarimetric snapshots of 3I/Atlas surfaced in late July, igniting immediate buzz mere hours later. Dr. Tony Santana Ros and his team at the Instituto de Astrofísica de Andalucía had finalized adjustments on a batch of Nordic optical telescope frames. They anticipated the standard nebulous veil, unstructured, bland, like interstellar mist. Rather, the resulting profiles formed a precise, abrupt slope featuring a negative segment that plunged even steeper and sharp. More striking than any feature listed in the directory was the level of linear polarization, calculated from the angle between the incoming solar rays and the light scattered by the dust particles, which hit -2.8% at a phase angle slightly exceeding 6 degrees. This figure aligns more closely with those from remote centaurs rather than standard comets. The shift, when polarization flips from negative to positive, occurred precisely at 17 degrees. Once again, this mirrors traits of bodies in the solar system's outer fringes, not the warmer inner regions where comets usually dwell. Santana-Ross recalls that pivotal instant vividly. We just managed to secure sufficient exposures to capture the coma's features before its development advanced further. Every fresh image altered our understanding. Yet, as the group refined their data processing tools while hunting for the anticipated circular structures, the resulting images stayed remarkably even. No evidence of rings emerged, nor any dual-layered envelope. Only a consistent expanse. Verifications using the FIRS-2 instrument on the Very Large Telescope in Chile and the Rosen Observatory in Bulgaria upheld these findings. Any fluctuations in polarization within the coma fell under 0.2%, comfortably inside the limits of detector sensitivity. Simulated datasets crafted to detect concealed patterns yielded identical results. The coma's form proved seamless, its polarization profile striking, though the positional charts revealed nothing further. The lack of structured rings in no way lessened the astonishment. Just the phase angle pattern distinguished 3I/Atlas distinctly. That profound and slender negative segment suggested dust particles bigger and more somber than in ordinary comets, perhaps clustered forms infused with organic materials and ices forged in the solar system's most frigid zones. Simulations tailored for inner solar system comets couldn't replicate the profile without adopting traits from diminutive trans-Neptunian bodies such as Pholus. This presented the researchers with a conundrum, an entity resembling a centaur in appearance, behaving like an interstellar interloper, and dispersing light unlike any prior comet. The observations were unequivocal, even if the fundamental mechanisms remained elusive. To Santana-Ross and colleagues, the real revelation lay not in the missing rings, but in the undeniable indication that 3I/Atlas defies conventional categories. Interstellar dust is typically envisioned as a haphazard assortment of minute particles, molded and dispersed by solar radiation and the solar wind's influence. For 3I/Atlas, however, the data suggest a far more exceptional scenario. The polarization signature, featuring a marked negative extension and an abrupt turnaround at 17 degrees, indicates substantial, uneven clumps. These differ from the dense, luminous particles common in most comets. Rather, they resemble fluffy, open networks interlaced with organics and ice, akin to snarled meshes instead of sleek pebbles. These clusters diffuse light in patterns seldom witnessed closer to the sun, implying birthplaces in icier, more shadowed realms. The coma's polarization distribution introduces yet another twist to the enigma. Should plasma influences or constructed casings be influencing the particles, prominent loops or zones would show up as defined, methodical configurations in the observations. But the coma displays evenness, with polarization shifts under 0.2% throughout the surveyed areas. Separate observations via FIRS-2, ALPHOSC, and Rosen affirm this consistency. No traces of outflows, collision boundaries, or ionized gas disturbances appear. The results steadfastly highlight a collection of sizable, shadowy clumps akin to those on Centaur Pholus and certain compact trans-Neptunian objects. This similarity runs deeper than surface level. The intense negative polarization dip and reddish spectral tilt both signify particles weathered over eons in the solar system's extremities, bombarded by radiation and encrusted with intricate organics called tholins. In the case of 3I/Atlas, the coma serves as an archive of another star's scattered remnants. Every clump retains hints of its genesis and molecular history. The missing aligned rings limits possible interpretations. Over plasma-fueled or contrived sources, the facts support innate, uncommon particle clumping. Substances forged by cosmic erosion, far beyond our sun, now traversing our heavens for the initial occasion. One snapshot taken in the early morning of September 7th from Namibia's elevated plains sent ripples through the astronomical community. The central body shone with a brilliant, nearly fluorescent green, shockingly luminous against the velvet blackness. The shooter, renowned for documenting elusive comet sightings, had deployed a complete array of filters, anticipating the customary crimson tone featured in all prior research accounts. To their surprise, the detector captured an unexpected shade, green, as though the cosmic wanderer had traded its time-worn, eroded mantle for a vibrant, dynamic one. Soon after, the photos circulated via astronomical channels and reached the desks of expert watchers. The bewilderment spread quickly. Every earlier spectrum, from the Nordic Optical Telescope to the JWST's near-infrared examinations, had revealed a sharp red gradient, 18% per 1,000 angstroms, redder than most comets rival the Centaurs and Pholus along with the dimmest trans-Neptunian bodies in terms of hue. That deep crimson wasn't random. It signaled particles pummeled by cosmic radiation, layered with organic tholins, and molded in the frigid voids between stars. But in just one evening, the visitor glowed emerald, as though its composition had altered on the spot. Typically, a comet's green hue stems from the C2 molecule, which fluoresces upon disintegration by solar rays. However, spectra captured days earlier at high detail from sites in Chile and La Palma revealed scant C2 activity, effectively dismissing the conventional theory. Experts in chemistry proposed alternatives, like faint traces of CN or possibly CO+ involvement, yet neither showed up in notable quantities. A few speculated on ultra-fine ice particles diffracting light via Rayleigh effects as the object's dust cloud changed. Others questioned whether the camera filter or detector quirks had boosted a brief, narrowband flare. Discussions flooded preprint archives and online forums, with groups pursuing each fresh hypothesis to account for the odd coloration. The imaging team's unprocessed data, made public for scrutiny, verified the phenomenon wasn't due to editing errors. Hobbyists in southern Africa also noted a comparable greenish cast, albeit less vivid than the initial capture. In under 2 days, pro facilities worldwide redirected scopes toward it, aiming to spot a recurrence. Nothing materialized. The emerald faded abruptly, sparking a slew of unresolved puzzles. Could this have been a short-lived chemical flare-up, an uncommon diffraction occurrence, or the initial sign of some undocumented dynamic in cometary behavior? One thing was clear. 3I/Atlas defied the norms of both comets and centaurs, broadening the divide between observations and interpretations. Every project scheduler has marked October 3rd in bold. On that date, 3I/Atlas will skim past Mars, near enough for the planet's orbiting probes to aim their lenses and analyzers at an authentic extrasolar nucleus. Crews from MAVEN, ExoMars's TGO, and HOPE have invested weeks weighing the hazards. Debris in the envelope might endanger delicate gear, yet the prospect of imaging an alien core proves an irresistible draw for discovery. NASA and ESA have planned brief observation pushes, betting on unobscured views as Atlas navigates Mars's vicinity. Should the dust veil dissipate sufficiently, sharp photos of the heart could narrow the diameter guesses, from a 50 kilometers range, down to a precise figure. Such insights would dispel long-standing debates in mere snapshots. Following the Mars encounter, the body will duck behind the Sun for almost a week, entering Superior Conjunction on October 21st. Earthly scopes will go blind during this gap, when unforeseen events might unfold unobserved. Preset algorithms and notification systems stand ready to flag any irregularities after emergence, like a sharp brightness surge, trajectory shift, or fresh eruption amid maximum solar warmth. Global skywatchers are on edge. For now, Atlas resurfaces mere days prior to its perihelion on October 29th. These tight schedules have ignited buzz not only over potential sightings, but also overlooked chances. Certain scientists muse that the envelope's even texture and extent go beyond routine vapor release. Suppose the dust casing serves as a defensive barrier, either designed or adapted, to shield the center during its plunge into the inner system. A dual-tiered coma, assuming it's real, might function like an ionized veil, deflecting photons and fending off ions. On the fringes of the web, notions of intentional camouflage circulate, a covering that alters its shine to conceal the interior. No proof supports artificial tweaks, but the thing's aversion to fitting known molds leaves room for the most outlandish ideas. For the science squads, much rides on this. A solid view of the nucleus might overhaul interstellar studies. A botched chance could bury its secrets for generations or eternity. The tale of 3I/Atlas now pivots on a few crucial viewing slots. It's a contest with remoteness, luminosity, and solar glare. No matter if the upcoming shots uncover a standard wanderer or an enigma, the next month will shape the inquiries astronomers pursue ahead. Its profound scarlet tone, gauged at an 18% slope per 1,000 angstroms, brands it unmistakably extrasolar. Still, the green glow snapped on September 7th challenges basic reactions. Polarization readings from July and August uncovered organized features absent in ordinary comets, prompting fresh probes into its structure and roots. Even after extensive scrutiny, the core's dimensions stay vague, with projections from 0.2 to 50 kilometers. As Comet 3I/Atlas draws near its perihelion on October 29th following a near encounter with Mars, experts continue to argue over its exact category and remain alert for further revelations. The saga of 3I/Atlas demonstrates that despite cutting-edge technology and international partnerships, certain enigmas linger. The object's genuine character and the insights it provides into cosmic wanderers from beyond our solar system continue to elude definitive answers.